start it out with an easy one. Aluminum metal and nitrogen. Okay. First thing you gotta determine, does this fit any of the special cases that I gave you?
No.
No. There are no special cases, so you don't have to worry about a special case. How do you know that you don't have to worry about a special case? Because it's basically two elements. So all this is an elemental combination. You are just combining two elements. So, take a minute, see if you can figure this out. I'm balancing. Aluminum plus diatomic nitrogen. You got aluminum, solid aluminum. And nitrogen gas. What are we going to get? What are we going to get? First thing you got to do is you got to make sure that your formula is right. How do aluminum and nitrogen combine? How do aluminum and nitrogen combine? How would they combine? What would be the compound, formula for the compound of aluminum and nitrogen? So, James, what would be the formula for aluminum and nitrogen combined?
2ALN.
2ALN? Okay, well, what's the charge on aluminum? Negative
Positive.
3. Positive 3. And what's normally the charge on nitrogen? Negative 3. Okay. So the formula would be ALN. Okay. And then how would I balance this out?
2AL and then 2ALN.
2AL and 2ALN. Sure, you want to come and watch? You can.
I'm gonna watch kids' heads explode.
We're just doing some
Advanced cam.
advanced cam.
And Mason's head hasn't exploded?
Not yet.
Impressive.
Mm-hmm.
Well, I was in the neighborhood, so I figured I'd say hi.
Well, it's nice to see you.
Yeah. They look thrilled.
They always do. This is a really exciting group, can't you tell?
Well, Sawyer's about to sleep.
Sawyer's always fun, so.
Not much has changed.
Not much.
Alright, let's
Back
see.
there. Okay.
I didn't even hear him knock on the door. I was like, you like went over there and opened the door, I'm like, what's he doing?
I just hear random noises. Alright, 2AL plus N2. Okay, so it gives me 2ALN. Good. Alright, let's do another one here. I'll take calcium. And okay, calcium and phosphorus normally shows up as P4. Okay? Alright, what would be the correct balanced equation for this? is the formula for calcium and phosphorus when it comes together?
Ca3, P2.
Ca3, P2, okay? Because calcium normally has a +2 charge. Phosphorus normally has a -3. So it'll be Ca3, P2. That makes sense? Okay? Now, how do I balance this?
6.
Okay?
Or 0 and then 2.
I'll say 1
Yeah.
and then 2. Yep. So the coefficient would be 6, 1, 2. Okay? Good. Sorry. Maybe mix that up. Okay. Lithium oxide and water. First of all, is this a special situation?
Yes.
Yeah.
Yes. How do you know right away I don't have two elements? You betcha. If I've all of a sudden got a compound in there, I gotta start looking. My special situation. So I have a metal oxide and water. Okay? So I have Li2O plus water. Okay? Special situation then. What happens if I put a metal oxide and I mix it with water? Okay? What's that? I get a metal hydroxide, right? So if I put lithium oxide and water, I should get lithium hydroxide. Alright? Make eye contact, Mason. Mason, do you know the formula for lithium hydroxide?
No.
What's the charge on lithium?
+1.
+1. So I know I'm going to have lithium, which is a +1. What's the formula for the hydroxide polyatomic? Anybody? What's the formula? OH with a
-1, +1. Oh, -1.
-1. Okay? +1, -1, +1. Yeah, -1. So if I have lithium and hydroxide put together, what's the formula for lithium hydroxide?
LiOH.
LiOH. Alright, so now I have my formula written correctly. So, how do I balance?
2 in front of the second, 1 on the right of the arrow.
The LiOH.
Yeah, right there.
That gives me 2 lithiums, 2 oxygens, 2 hydrogens. I'm balanced.
So I thought you always had to put the H first though.
No, in the case of hydroxide, that is the polyatomic, so the OH stays together.
Alright.
In the case of hydroxide, that is OH. That is the polyatomic. Okay?
Explain that again, please.
Okay.
Well, I just think the H is, I don't know.
Alright, the reason why you think is because the H is over here, right? Alright, it's a good question. In chemistry, and I mentioned this a little bit on Friday, but I don't think everybody caught it. When we do reactions, this is how we treat. This is kind of how we treat water. HOH. We treat it as hydrogen hydroxide. So we actually have the hydroxide ion there. The only problem is we have this other H, this hydrogen that's positive. But since we're doing this, what will happen is this OH will go here, this hydrogen will go with this oxygen, creating another hydroxide. The reason why we don't put the H first is because we're dealing with the hydroxide polyatomic. And the hydroxide polyatomic is an OH. That's just how it arranges itself. And the reason, and in this case, this hydrogen right here changes a little bit because the lithium is a little stronger metal. So it takes precedence, it becomes the true positive metal here, and then the OH together takes on the negative charge. Okay? And actually in this OH, this hydrogen does keep its positive charge because oxygen's a -2, hydrogen's a +1, which gives OH a negative charge. It keeps its positive oxidation states. But that's one of our rules. In fact, that is one of our first, that's our first special situation. Okay? So let's do another one. Okay? So in this case, Al2O3 plus H2O. What am I going to make here? Now, it's very similar to the last one. I have a metal oxide, and I have water. So I'm going to make a metal hydroxide. Okay? So I'm going to make that metal hydroxide. By making that metal hydroxide, so I'm going to make aluminum hydroxide. What is the formula for aluminum?
AlOH3.
You got it, Shay.
Dang.
Okay?
Copy off my page.
Okay. AlOH3. Now, if we do this then, we got to make sure everything's balanced. Okay? We've got to make sure everything's balanced. How am I going to balance this?
You could do 2 and some of the AlOH to make it, no you can't. Yeah, but the 2's not the right number. If you look at it, you have 4 oxygens, you need to have 8, you have to do 8.
Should be OH.
OH what? No, because aluminum typically has a +3 charge, and hydroxide typically has a -1 charge. So it's got to be AlOH3. They always come together according to their oxidation states. Okay?